I'd like you to imagine for a minute grabbing a hammer by the handle and pounding in a nail. You know how that hammer feels as you swing it? You can kind of feel that. You ever hit that nail and bend it? I've hit the nail and bent it. So then sometimes you can't fit that claw of the hammer in there to pull it back out, right? You have to use a pliers, or you have to use a channel locks or a vice grips or something like that. What we're going to spend the time talking about over the next 50 minutes is another tool in the toolbox to pull that nail out. What I'm talking about by that is when we migrate stuff, we're going to look at containers as a tool to do migration. It's certainly not needed to migrate .NET apps, and the traditional way works just fine, but it's another tool for your toolbox, and we're going to talk about the benefits that containers can offer for those toolboxes, in your toolbox for moving that. So my name is Brian Lewis. I'm a solutions architect with AWS. And with me, I have the luck of having Nikki Klein as my co-presenter.
Hi, everyone. Hope you're having a great reInvent so far. I'm a technical evangelist for AWS, so if you're not familiar with the title, what that means is that they pay me to play with the cool stuff that they build and then show other people how cool it is. It's basically my job.
Very cool. Oh, I should probably forward the slide. You don't have to.
Oh, yeah. So what we're going to cover today is obviously the basics, so why containers for .NET applications, how to containerize your legacy .NET application, and then how to deploy it and get it running on ECS. We're going to cover all of them, hopefully in enough detail to get you started, and then if you have more questions at the end, we'll definitely take them.
Oh, and just a pointer to the gentleman in back, our timer is not counting down, and I can talk forever if we don't start the timer. Just saying. All right.
Okay, so I think it's important to talk about where we've been, to talk about where we're going. So, is it not working?
Nope.
Cool.
You have to push that button.
I didn't pray to the demo gods today, so just giving you a heads up on that one.
That could be a problem.
I know. So this is a really awesome diagram because most people haven't seen it. So we're all familiar with .NET Framework 4.6. Now we're on 4.7. Originally, when Microsoft was launching .NET Core, they were going to call it .NET Core 5. And that's to indicate that they really saw it as the next step in the .NET world. They were going to move away from Framework and go directly to Core. Then, obviously, as you all know, they changed their minds at the last minute, and now it's 1.0, 2.0, 2.1, 3, so on. I just think that this diagram is really cool because it shows that Microsoft sees .NET Core as the future of .NET. So most people are trying to migrate from Framework to Core. That's a really big hassle to do all of that in one go. So containers is another way that you can do it in pieces. And we're going to talk a little bit about that at the end.
So I did pull this and this graphic off of, it's out on the net, it's Microsoft's graphic. And that's why I pulled it and used it. We didn't create that and put .NET Core 5, right? That was theirs. And then they changed. The other thing to think about as they go forward, right now we're on .NET Framework 4.7.
4.7.
Is it 4.7? I thought it might have been a 0.1 after that now, but anyway.
I don't even know.
And then .NET Core 2.1. There's another .NET Core coming in this next year that is going to add forms and all kinds of desktop stuff, and it might make it easier for us to migrate our legacy apps by recompiling to Core, which would be really awesome, but we'll see when that ships, what happens there. Where it exists today is .NET Core apps and .NET Framework apps are very different, and so, we can't just recompile and get to that new platform. So that's why we have to look at the 4.6 and 4.7 framework as we run all these things that we have in the enterprise that either you've spent years writing or someone you purchase it from wrote it, and it's why we have to live with it.
So there is this common perception that AWS does not love .NET. I'm very aware of this perception. So I just wanted to let you know that that's not true. And I specifically put this slide in here to let you know because these are all the recent announcements that we've made. This isn't even a complete list, but specifically for .NET developers, we are spending lots of time in enhancing the tools and adding support to services that you don't currently have. And so I just wanted to make this known if you weren't aware of these announcements. The best place to go to keep up with .NET news, specifically on AWS, is aws.amazon.com/net. That was launched in July. And it's also great for code samples, step-by-step guides, anything you could possibly need as a .NET developer on AWS is the best place to go.
And to jump onto that, Nikki created the .NET website for AWS. And when I say that, she managed this whole thing to build this site. And is it AWS.com/
AWS.amazon.com/net.
/net. And so there's all kinds of resources there, as well as a spot to sign up for an email list to get information forwarded to you when things change, because some people want to know when do the drivers change on the Windows images and all that other type of stuff.
Yeah, you can subscribe specifically to .NET News, so you don't have to get all of the AWS announcements. You can get the ones just related to Windows and .NET.
Okay, and so when we look at Windows, to understand what Microsoft's done here with the containers, Linux containers have been out for a while. Windows containers is a lot newer. What Microsoft did is in Server 2016, they built the infrastructure to put protections up between the different applications, and to, when you call to look at the hard drive, it might hide sections of the hard drive, that kind of stuff. That's what containers basically do. Very similar to VMs, except they don't have the overhead of a VM. Now, in that, we have Nano Server, which is the smallest copy of Windows that you can put out there. Nano Server is great for running containers. However, it doesn't work for us in this session today because it's great for running .NET Core. It does not work to run .NET traditional applications. When we go to Server Core, that's what we have to use for this. There's two other install options, and one is Server Core and one is Full-Blown Server. Full-Blown Server has the full entire GUI. Server Core has the graphical drivers and environment, but when you run the GUI, you get a command prompt box in the GUI. You don't get the start menu. You don't get the extra pieces there. And so the difference there is Server Core is somewhere around 12 gig, I think, and then Full-Blown Server is somewhere around 20 gig. So it saves some space, but in comparison to if you want to run a Linux container, it's too big of an audience to ask you if anybody knows, because the guys in the back I'll never hear. But it's about, 64 megabytes for a Linux container, something around there. So quite a bit of difference. Nano Server gets closer to that, but the size is quite a bit different. We'll talk a bit about Server Core today as we look at this. So Nano Server, I already mentioned it. It's 64-bit apps, .NET Core only, and it's doesn't even, with the latest version, we'll talk about versions in a second, it's not even included with PowerShell by default. Now, Server Core is the one we're going to spend the time on today. It's got full PowerShell. It's got full-blown .NET support. It's got the ability to run SQL Server. It's got the ability to run pretty much anything, other than RDP desktop type stuff. So it's great for running your traditional apps. Now, when we look at sizes, let's talk a little bit about what the sizes of the OSs were. Server 2016 shipped initially, right? And Server Core was about 8 gigabytes in size from a download, and then it would expand and be a little bit bigger as the install footprint on disk. Now, if you look at Server 2016 version 1709, it's smaller. They dropped the size almost in half. And when you look at 1803, it's even smaller. And for those of you who aren't aware, this is Microsoft's new thing. They're shipping a new version of Server. It looks like twice a year. And so Server 2016 is the main release. And then 1709 was the next release. The way that works, it's just like Windows 10. 1709 stands for 2017, and then 09 for September. And so the 1803 release was the 2018 release from March. And we just had a release of Server 2019 in September that is still kind of rolling out, so it's not fully released yet. But that is basically a 1809 release of Server, but it's also going to require new CALs and that stuff because they did change the server name as well, where these ones all use the same CALs. So one of the things to notice is they've really been working on the size of these things. They've been doing a lot of work in this specifically for containers. That's got the most changes in these new versions they've been doing. And so in 2019, there's a ton of changes. And as soon as that is really widely available, anybody who's doing Windows containers will most likely move to that because there's some huge, huge improvements and goodness there.
So why containers? Well, these are 3 really good reasons. You can really take advantage of your operating system, deployment runtime consistency. If you can't see my shirt, works on my machine. How many people have said
wait,
that?
let me see.
I've said that.
Works on
a
my
lot of
machine.
times. Scaling. So we're going to cover these a little bit more, but this is just an overview of why containers for legacy .NET apps.
So that's a dev machine, right? I mean, it's a dev thing, right? That's the ops thing. So I don't know if we covered that. We'll specifically cover, don't we have a part where we go? All right, so I'll drop it till later. So why containers for legacy apps? If you think about it, the hypervisor, right, did a great job of letting us start to use the hardware fully. Things would sit and run at 5, 10, 15, 20% utilization. We've got a lot more server there, so we virtualized. And then we got some other great abilities with that, which is we could spin up new servers as long as we had more space in the hypervisor cluster, whatever we were running. But there are some limitations there in the sense that in the cloud, I'm already on a virtual machine, and a hypervisor on top of a hypervisor really is very poor performance. There are some out there that can work in that fashion, but if you've ever run it, it significantly slows down the machines. It's not ready for production to do that kind of work. But what does work really well is to do a container, because what a container does is instead of building a whole new machine and emulating that, it runs on the same Windows kernel or the same kernel for the Linux side as well. And then what it does as far as the containers, they run secluded from each other and they can't see each other. And so, but they share the kernel. So it basically lets you, on the same piece of hardware, if I was to do containers, and maybe I can run 100 apps on there, in virtual machines, I might do 10 or 20 apps, right? It's a lot lighter weight. The processing power is really, it runs like it's native on the machine. And so there's some really great benefits to being able to fully utilize, especially in the cloud, because our instances are already virtual machined. So if I want to load those up and fully utilize them, the containers is a great tool to do that. So that processes, the way it does work, the kernel is the same across all of them, but in each container, all the above processes get added in. So they don't share any other processes other than the kernel. When we look at that, I guess I should go back. When we look at that, it works really well in the cloud that we have a hypervisor, then we have Server 2016 or Linux, and then we have the Docker containers up on top of that. And that's what we would suggest doing, because when I migrate these apps in, I can really scale them up, and we'll talk more about that scale in a second.
You can also decrease your Windows licensing costs for anyone that's concerned.
If you care about that kind of thing.
Yeah, if you care about that kind of thing. Deployment runtime consistency. So we touched on this briefly, but basically if the image is running on dev, test, and prod, you're going to have the exact same experience no matter where you run it. Usually when you have problems like it works on my machine, it's usually a dependency issue. In this case, all the dependencies are contained within the image, so you get the same experience across the board, which is great, because you rarely now hear developers say it works on my machine.
Now notice I'm not wearing a shirt that says it works on my machine, because I'm the ops guy. Nikki's the coding guy. So
DevOps.
Yeah.
He hates me.
You know what? Not anymore. Not anymore with containers.
Oh, you like me now?
Yeah.
This is new.
So then we can talk about cowboy coding, was it?
Oh, right. So how many people have ever tried to fix a bug in production? Okay, right. So this is formerly known as cowboy coding from one of the places that I worked. And so, yeah, hopefully you will not have to do this if you're using containers ever again. Because, again, deployment, runtime, consistency across all your environments. So no more fixing bugs in production.
The process that their company used was phenomenal when I heard about it. They had a cowboy hat, a nice, 10-gallon cowboy hat. And so what happened when you would code and fix production workloads, the people coming by to talk to you about what happened on Seinfeld.
No, don't talk to me. I got the cowboy hat on. I'm
the hat
coding
goes
in
on.
production.
Everybody knows not to bother you, which I thought was a fantastic process.
So this is what a Docker file looks like if you've never seen one before. And what's interesting is that each line of the Docker file actually becomes a layer in the Docker image. Hit the next. Yeah, there you go. And so then that's how you actually create the immutable image. And then the immutable image then becomes the image at the base of your container, and then there's a read-write layer on top of it. The benefits of this is that obviously you can reuse your image for multiple applications. So you can create one image and just reuse it a million different times for all the apps that are running some of the same things. So like in this slide, for example, I made one image, and now I have two applications that are using that same image. So obviously, Dockerfile, you only write one Dockerfile, so a lot of code reuse. You don't have to keep rewriting the same stuff.
So to really get this idea through, think about running 100 apps on the server. Now, they're not all the same app. In this slide, it looks like they're exactly the same app. But these could be different .NET apps. And what we load that's the same is that Windows Server Core, that download, it was 7 gig, right? So that's downloaded once, and then all the apps all refer to that same one download because it's immutable. It doesn't change then after that. And then they build their layer on top of that. And so when you think about that, if I've got 100 apps on this server, in the traditional world of virtual machines, that would be 700 gigabytes of disk space that would use. And in Docker, it will use 7 gigabytes. So huge savings in disk space. And I know, disk is cheap, but if you think about, in comparison to Linux containers, right? They're small, so they come down a lot faster when I go and add them to a machine. But if I've already got the server core preloaded on that machine, then I just have to load the differences, whether it's IIS that's built on top of there, or whether it's just my .NET code, my specific 50 megabytes, 100 megabytes, or however big your app is, then that's the top layer, and that's all you have to download then. So it makes these images competitive in speed after you put that base layer on there to the brethren in the Linux side. So it's really, really impressive that this containerization layering of file systems. We could do this in virtualization or in other things, and we just, nobody seems to have gotten around to doing that. So there's nothing special with containerization for here, except that that's how it's done. Oh, is this my slide? Mm-hmm. So the benefits of Windows containers.
We just covered a couple of them.
One of the reasons that this whole session came about is when we put things in containers on premises, it makes it real simple to move the servers around. So as far as moving to the cloud and moving back out of the cloud and moving to someone else's cloud, all of that is very simple then because it's all running on top of that container abstraction layer. So it's simple.
If you're lifting and shifting into containers, it's easy to continue modernizing your application. Instead of trying to modernize it before you move to the cloud, you can lift and shift into containers and then continue modernizing on top of that by breaking out pieces of your application into containers that maybe you write in .NET Core.
So another benefit, we already talked about how we can put lots of them on the same machine so we can lower the costs because you're going to fully utilize that piece of hardware or that virtual machine. Another thing is that the server boot times, since we're not really restarting a server, if you think about your server boot time, when you hit the hardware button on your on-premises server, it's ridiculous, especially if you have to count all the RAM on the server, right? It takes 5 minutes, even more sometimes, to boot your server. When we go to virtualization, it's a little bit better, and it's only taking a minute or so to boot your server. In containers, it's sub 1 second, which is really nice, especially because if we're doing things and we have a server fail, right? Due to the crappy code, technical term.
Whoa. It is not crappy.
But if for some reason there's a problem where the code actually drops and not the hardware, there's services that watch for that, and we'll talk more about those, and restarts it. If the server's down for less than a second, the end users really see it as a glitch, and they see glitches all the time, so they don't really think it was down, and we won't tell them it was down. So, that 1 second boot time is kind of nice.
So we are going to use Nerd Dinner for our demonstration. If you're not familiar with this, Scott Hanselman built this application way back when Microsoft released MVC 1.0, and he's continued to update it all the way to 4.5, which is now considered legacy. So we are going to use Nerd Dinner running .NET Framework 4.5, and we're going to containerize that today.
If you want to grab the code.
Oh yeah, it's on GitHub. It's on my GitHub. All of the directions and all of the basically commands I'm going to write today are in a markdown file called directions inside the repo, so you can replicate everything we did today.
Except we didn't sacrifice any chickens, so it may be difficult to replicate any failures we have today, but we'll see. You got it?
Go.
You got to get your machine on, and then you can do it. First failure, the machine turned off.
It's fine. Again, I told you I didn't pray to the demo gods, so we already have that going for us. Okay, so this is Nerd Dinner. This is a .NET Framework application, so you can see there's a web config. All the good stuff is in here. And at the root of my project, there is a folder called DB, and inside contains the Docker file that I wrote to containerize a SQL database, which is part of our application, along with a PowerShell script. And then in the web folder is a Docker file to containerize the actual application. So let's take a look at that for a second. So all we're doing here, let me hide that terminal for a second. By the way, let me step back for a second. I'm using Visual Studio Code because Visual Studio and I have officially divorced because it runs right over me as I'm trying to write my Docker file. I don't know if you've ever experienced adding Docker support to your Visual Studio IDE, but for me, as soon as I save the Docker file, it just starts trying to build it, and I'm not ready for that yet. So in order to make sure that this demo happens at my pace, we're using Visual Studio Code, which is actually now what I use all the time now. Visual Studio went out the window, fortunately. So back to the Docker file. So if you look at the first statement, it says from Microsoft.NET Framework. So I'm actually using a Microsoft base image here. And the cool thing is Microsoft actually releases a ton of images for all their versions of .NET Framework, .NET Core. I think .NET Framework goes all the way back to 3.5, if you're curious. And then .NET Core, they've released every single version. So you can use one of their base images as a starting point to build your application. So this Docker file is a multi-stage Docker file. And the reason that it's a multi-stage Docker file is because what I do in the first part is I actually build the application. So you see the last line, it says run ms build. I copy over the files, I run NuGet restore, and then I run ms build. And then I throw away this container. I no longer need it anymore. And then I copy over the DLLs to the image that I would like to run my application on, which is now Windows Server Core. I just got done talking about it. So basically, why I do this is because none of the source code is on that final image, and I don't want it to be there because I want my image to be the smallest humanly possible, as we talked about. And there's no need for the source code to be there. I just need the DLLs. So that's all that's going with me.
But raises security doing that as well.
Yeah, also that's a security issue, so you wouldn't want to do that. So we're going to actually build this image right now. So the command, if you're not familiar, is docker image build. And then we're going to give it a parameter of -f. We're going to tell it where to find our Docker file. If your Docker file is sitting at the root of your project, you do not need to do this. But again, my Docker files are in 2 different folders. So it's very easy to find which one is which. So -f. And then I'm going to give it a tag so I can find it later of nerddinner/web. And then I'm going to put the period on there to indicate that this is where I wanted to start building from. If you forget that period, you'll cry. Trust me, I've done it a lot of times. So yeah, it's successfully built. And that's basically how you build the app image. So now we only have the app image built. We do not have the database built. And we need both images to run this application.
OK. I was just going to throw in 2 thoughts here. One was she mentioned that this is Visual Studio Code. A lot of the videos and stuff, if you watch and go to Microsoft's website, they're using code now and not full-blown Visual Studio. Certainly here it was kind of funny as Nikki started to go down the path of using Visual Studio and manually edit her Docker file so she could demo it and clean it up and show it to you guys. Visual Studio doesn't like you manually editing it. It wants to control it all yourself. And so
it really wants all the power.
It was rather hilarious to watch.
I really needed the granular control for the purposes of this demonstration in case I changed anything live in the Docker file, or it just starts going like before I'm even like ready for it to go. So there's no typing a command in Visual Studio. There's just, it goes, and it does some kind of like magic in the background. It's like typical Visual Studio fashion. I have no idea what magic it's doing, but I'm not a fan, so.
Okay, and so SQL Server is, we're gonna have that run in a container as well here. You don't have to. You could hit some other, as we talked about the toolbox before, we could use another players or whatever. We could use RDS. We could use just an EC2 instance. We could run it on premises or somewhere else. But if we want to put it into the container, that does make it easy and lets us do this immutable image pipeline work. And there's only certain ways to get it. And that way is to do a Docker pull Microsoft/Microsoft SQL Server Windows. You basically pull it out of a repository, the Docker repository. Now, we didn't talk much about the repository, but one of the things, not only do we build the files in these image layers, but then when you have that image, you put it into this file share called a repository, a Docker repository. Docker has one that's you can put your files into.
We have one.
We have one. We have in your account. There are
ECR.
Yep, ECR. There's other repositories out there, but the repositories are really cool in the sense that that's where those images are contained. When you build it on your laptop or in your dev machine, then you push it to there, and when you want to pull it off of there, you just pull it from there, and that's a huge piece of what Docker does. The only legal way to get SQL Server is to pull the images that are pre-built for you. Even though you could grab a Windows image and then basically do an interactive command prompt in there and then go install SQL, that is licensing not allowed, although I'm not an attorney, but I believe that that is how I inferred it. Use at your own risk. But this is what their website says is how to get it. And they do have both SQL Server on Linux as well as on Windows. It's actually harder to find the Windows ones for Docker than it is for the Linux ones because most people doing Docker are doing Linux. Which brings us to the data. You probably want to keep your data.
Probably.
So
maybe.
When I put my data, we talked about these, we've got this file stack of our app and OS and all that stuff. If I've got SQL there and I save my stuff to that server, and then the idea is that these servers, we can throw them away, I would just throw away my data, which is probably not a good idea. Or before I killed that server, I would have to upload it to a repository, which that is not the way to do it. So the way to do it is to use data volumes, to use a file share, to use a mounted host directory. Now the caveats there are today, you can use data volume containers on either Windows or Linux. On Windows, you can use an SMB 3.2 file share for your SQL Server database backend, but you can't do that with Linux because Linux doesn't support the 3.2 protocol.
We have one thing over them.
And then as far as mounting the host directory as part of the file system, you can do that today on Linux, but you can't do that on Windows. Now, a lot of that changes with Server 2019, and when we get Server 2019 fully incorporated, that does let you do the data volumes. That does do a lot of other stuff for containers. And so it would just be a month or so, I think, before we get full 2019 everywhere. And everybody doing Windows containers, I'm pretty sure will jump up to that version when it's fully available.
Yeah, we didn't do any of our stuff using Windows Server 2019, but I highly suggest that you check it out after this presentation because it does add a lot of functionality back to Windows containers that was previously missing that Linux containers had. Okay, so now we need to containerize our database. We're back. All right, so let's go to our database folder. So I have two things in here. I have a Docker file, I have a PowerShell script, and I have a Bach file. All I'm doing in the PowerShell script is just restoring the database from the Bach file to get my data in there.
And can I inject what a Bach file is? That's a developer way of saying the backup file that SQL Server creates.
Sorry.
That's what we in the ops world call it.
Got it. We have different vocabulary, so.
A little bit.
So this Docker file should look fairly similar to the other one. Again, I'm using one of Microsoft's base images. I'm using Microsoft SQL Server Windows Expressed. And then I'm explicitly stating that I'd like to use PowerShell as my shell, exposing the port 1433, copying over the BOK file or the backup file, however you want to say it. And then at the end, this command is just telling the image that right when the container starts up, I want the PowerShell script to run first thing. So you can also use entry point here or command. They do a little bit different things, but for the purposes of what we're doing, we're going to use command CMD. And then, let's see, I'll show you the PowerShell script really fast if you're curious. All I'm doing is, again, just restoring from that BOK file. Yeah, that's basically it. So let's build our database image. Let me get some more real estate in here. So I'm going to go into the database folder, and I'm going to do docker image build. Same command. We're starting to get it now. I don't actually have to do this. I'm just doing this because it's good practice, and it helps you guys figure out what this parameter is doing. Again, it's telling Docker where to find the Docker file. Then this is the tag, so nerddinner/db, and then again the period because I want it right here. Done. That's what happens when you have things cached on your machine. It happens so fast. So let's actually run this now. So I have a Docker Compose file that I use to run both of these containers at the same time on one network. So this is my Docker Compose file that I wrote. So you can see that it's referring to both image tags. So these are the ones that I tagged it. All it's doing is creating a network called AppNet, which is a NAT network. It's telling both containers to use that network. This is a really important thing that Brian and I had fun with. You have to accept the EULA. If you don't accept the EULA, your container will just immediately tank. Fun times.
It doesn't just tank, it just turns off. And then you have to troubleshoot why your container won't
Just goes
start.
goodbye. Like starts up and then down. Yeah, so ports, it's all that's in here. Nothing fancy, but again, it's all in GitHub if you want to look at it. So we're just going to do Docker Compose to actually run this.
I wonder if that's enforceable in court.
What?
That you hit Y on the Docker file here, on the Docker Compose file. You just agreed to the EULA by doing that in code, but there's no,
Well, it's an environment variable.
I know, but what I'm saying is I wonder if they can prosecute you in court because you accepted the EULA. It just seems kind of silly. Although so does the website.
I don't know.
All right,
Not a lawyer.
bad tangent.
Okay, so Docker Compose is, again, -f, tell it where to find my Docker Compose file. It's a YAML file. And then I just call up -d. Then it's going to start up my containers. So we're going to touch on one of the benefits of running containers in Windows Server 2019. Because we're not doing that, we actually have to find the IP address to actually open this up locally in our browser, which I'm going to do in a second here. But if you are already using Windows Server 2019, you no longer have to do this. You can just use localhost and the port, which is a really nice enhancement for Windows Server 2019, because this is really lame to have to find the IP address every time.
This is the main reason that the Linux ops guys are laughing at the Windows ops guys in the container space. I'm
Right.
sure they'll find new reasons to in the future, but right now it's because they just go to localhost all the time, and we have to look up the IP address. But again, that changes in about a month, or as soon as you get 2019 loaded.
It's this long command that I can never remember because it's long and ugly.
Or you could do ipconfig for the ops guys.
Or you can do it that way. Either way.
You can do it in code, or you can just use ipconfig.
One or the other. Ops guy, dev. Let's go back to that for a second. Remember who you are. I do it this way. He does it a different way. We accomplish the same goal. Because we're friends, and we work together.
That's right.
So it's taking a second. It's just starting up both containers, and then we're just gonna view it in the browser really fast to see if it worked. Everybody cross your fingers and toes. I don't know why it's taking so long.
To fill time, another thing that takes really long that is interesting is when you upload your, once you build these and you want to upload your image to the repository, that upload takes a real long time because it runs through and compresses it a lot. And so when you upload and push, that takes a lot of time. When you download, downloads are pretty quick. What we decided, we're definitely not doing any demos of uploads, because one of your uploads, didn't that take hours?
Yes.
Yeah, and it downloaded in maybe 15 minutes. Even that, we're not going to look. But I'll show you some downloads.
I started it, and then I decided that I no longer could wait for it, and I went to bed, to give you an idea of how long it took. Yeah, it does take longer because it's compressing it as it uploads it, which is a nice feature for somebody that's pulling it down, but not for me.
Oh, and on this machine,
Dude,
it would take forever on this machine.
What the fuck is happening?
Her last machine she had in the airplane and had it on the floor. Bad idea number one.
Okay, it was in my backpack, just to tell you.
And then the gentleman who sat next to her spilt coffee onto said floor.
It was a pink drink.
Okay, a pink drink, sorry, not coffee. And it didn't say anything. So the machine basked in that the entire flight. And it was a nice Lenovo Carbon.
I'm just gonna try running.
And it killed it, along with all of the work that she had to recreate for this presentation.
Yeah, so I had to rewrite it. I wrote it twice.
But now they gave her another machine that is really
Ridiculously slow, which is why we're having these issues. I had a Lenovo Carbon X1, and now I have some kind of random HP that's a piece of crap. So.
Not that there's anything wrong with HP. We do want to make sure that we state that.
Well, I'm having an issue with it.
This specific model is just a little bit too slow for
We can come
a
back
dev
to
machine.
this. I don't know why it's deciding to be exceptionally slow at the minute. I ran this like a few hours ago in our Chalk Talk. It worked perfectly fine. It no longer wants to go.
Maybe it's because I loaded that browser session and that RDP session, which
No, that
all
can't
your
be
resources.
It. Oh, you're right. You're taking up all of my RAM.
By running Firefox and the RDP
My
client.
small amount of RAM. Okay, yeah, we should abort this mission.
All right.
It does work, I promise you. If you download it from GitHub and run it, it will work.
I'll show it working, because what she's done then is she's taken this stuff and she's pushed it to a repository in
Traditional
ECR.
fashion, I handed it off to ops.
In my demo, I'm going to pull it down from there and then run it on an EC2 instance, and then later I'll run it in basically a cluster, basically a container cluster, and we'll see all that.
Okay, so go
I
back.
didn't know you were pushing the button.
Sorry. What we just did is all in this little nice diagram. Step 4 we didn't get to because, as we said, it takes a very long time and we do not have all day. I'm sure you guys all have places to be. So we obviously built it, tested it. I did step 1 for you way before. We added a Docker file. We ran our Docker file. The Docker file built our application and then put the DLLs in a final container. We built our SQL Server container image, and we copied over a PowerShell script that would allow it to copy the BOC over, which restores the database right when the container starts up. And then we would push both of our images up to Amazon ECR. You do not have to push them to ECR. You can also push them to Docker Hub. Like, choose wherever you want to pick. It doesn't really matter to me. And that, because you can run your containers still on AWS, even if your images are in Docker Hub.
Or any other container registry, for that matter, that's on the internet. And then the other thing I think might be good to point out is we're doing the restore from that backup file. The reason we're doing that is it makes us a very self-contained environment that is easy to demo, and other people can take it and you guys can play with it, and it works great without having to go set up other stuff.
Right.
In production, we would never do that. We would have a SQL Server database somewhere, right? And we wouldn't be doing restores. We would just continually have that database running. But that's what we have set up.
So this goes back to the best practices of using a multi-stage Docker file. I think we talked about the benefits, but basically it will help you make your image the smallest amount possible, and you leave the source code behind and just continue on with the DLLs.
So Windows
all you.
containers. All right.
Did you pray to the demo gods?
I did
'Cause
not.
I told you, like, that was exactly what just happened.
All right, let's see. Let's switch over to your machine. It's not asleep yet. That's a good start.
It's thinking.
It's still
having
starting.
a really hard time with a lot of things.
All right, so I'm going to go into an RDP instance here. I'm remoted into a server of mine. This server is just an EC2 server in US East 1. And in this server, I have,
He's pulled down my images.
let's go with, I'm going to run the ISE. This is on your machine. Why is this doing that? Oh, because I can't see my start menu. Your start menu is not hiding. I'm going to tell your start menu to hide.
Okay.
If I can find it.
I knew we should have prayed to the demo gods.
All right.
Like, I was
I'll go
really
like
serious
this.
about that one.
How do I hide? I'm going to move it to the side then. How's that? Did that work? No.
Sure.
Would have been better to have my machine up here. All right.
Yeah.
Where's the lock?
What?
There it is, locked. All right, thank you. All right, let's do that. Let's do that. That'll be quick. All right, that is what I expected to see. All right. Whew. Oohs, ahs are welcome. That's the best demo yet. All right, so what we do first, once we have Docker installed on the Windows server, is we run a Docker pull command. And if we look at this here, let me zoom in a little bit. If we look at this here, I do Docker pull. I'm sorry? Oh, I thought someone commented. So I'm doing a Docker pull, and then I'm basically pulling from ECR, which is 805, that number, basically .amazon.com/nerddinnerdb. So the first thing I'm pulling is the DB. And if I run on that one, let's go. So what it says is it's not pulling it down. It already pulled it down. And that digest is the same, basically the hash. It's the same file. It knows it has the latest files because she hasn't pushed anything new up there. So that's done already. If I do a Docker pull on the other image, which I've already done as well, it should say the same thing. It's pulling. Oh, it's the same. We're all good to go. And then I have a choice. I can run it manually and do a Docker run and basically call those items. Another option is to use a Docker compose file. And it's really nice because it ties the network together, ties the machines together right away and sets it up so it's easy. I'll show you what that looks like. I'll bring up Visual Studio Code. And I have the compose file in there.
I've converted everyone.
It's basically the same compose file that
I
Nikki
want to
was
make it
using.
a little bigger.
Yep, let's go.
Yeah.
So if we look at this compose file, what I have is I have the image, and if you remember seeing this before in her Docker compose file, she just had the name nerddinnerdb on image because it was on her local machine. But this one's up in a repository, so it's got this unique number of the storage space, and then it's got the tag that this is the web. Right? So it's going to start the web server here, and it's going to map the ports. It's going to go to port 8020. That's going to be on my machine, and port 80 is going to be the one running in the container, and it's going to remap that. And then I've got, it says it depends on the nerddinner.db, which is the other image, and it's going to join this AppNet network.
That depends on just means that the DB container is going to start first.
And we certainly want the database up first, right? Because the app is going to try to connect to that. So then we've got the image here that's the exact same thing. We do have the accept EULA added into there. We've got port 1433 mapped, and it's on that network. And then it's using NAT, which NAT is the only networking type allowed in Windows Server 2016 for Docker containers. That changes in 2019, but right now NAT is the only network you can use. And so that's my compose file. And so when we execute that, that will start with a docker compose -f, that docker compose file,
See if you
bring
can
it up.
get it to go.
What do you mean, if? Now, so the red is due to that I'm in the ISE. If I was in a PowerShell window, we wouldn't see that. For some reason, the ISE PowerShell window has a problem with Docker commands, but it'll still function.
Okay, it's running.
And we'll see that it's up and running. right?
How did you get that running?
Ops guys. That's how it works. All right, so now I'm going to do a Docker PS for a process list, and we're going to see if it's up and running. And both of them are, which is good, because when we didn't have that Y in there, it would shut down automatically, and we'd only have one of them up and running. So we see it's up for 17 seconds and 26 seconds. It did start the DB first, and then the web, just like we told it to in the compose file. And the next part
All right, let's see it.
is to hit it. So we'll use a lovely browser here. And it will take a little bit because it is .NET Treasure Framework, and there we go. It's up and running.
It doesn't have Scott Hanselman's fancy
And that's Nerd Dinner.
design, but same app.
What a great app. But there we have it. From an ops perspective, all we did is have to pull it down from the registry, right? Whatever the developers built for us, we just pull and it runs and it works.
So he could run, we're showing this in an EC2 instance because he could actually run this as a test first before he deploys it to ECS. So maybe he pulls it down into an EC2 instance and that's his test environment. And then he later on, from the test, deploys it to ECS.
Yep, and so the way I could do, I mean, there's multiple ways you could do it, and you can certainly do it in code pipeline.
Yeah, you could use code pipeline.
There's another thing we could do, which is I test it here, it works, I push it to my repository, that's the production repository, and then we can have it automatically load from our automation engine. Whenever the repository changes, just pull the new images and basically drain the old ones and start the new ones. All right, back.
Okay, so these are some of our latest announcements for ECS for Windows Server. Actually, these are from the end of last year. So pay attention the rest of this week. We might see some more announcements for ECS for Windows. I have no idea what they are, so don't ask me. I literally have no idea. I think the coolest shout out from the last year's announcements would be that the ECS agent now runs as a native Windows service. So we just wanted to highlight that, the ECS team is working on improvements for Windows Server on ECS.
So we're going to take a quick video to look at a little bit about ECS.
If you're unfamiliar.
And then we'll continue after that. So, or we won't. How do we start this video? Press space.
Space.
Let's start.
Using Docker containers means that you can abstract away the software, operating system, and hardware configuration from your app and have a standard building block that you can run anywhere. But when you start deploying lots of these containers for lots of applications, managing all of these container clusters starts to get complicated pretty fast. Wouldn't it be nice if you could just focus on building containerized apps and leave the container deployment and scheduling and cluster configuration and management to a service that manages all of this? Introducing Amazon EC2 Container Service. Amazon EC2 Container Service is a highly scalable, high-performance container management service that allows you to run and manage distributed applications. EC2 Container Service allows you to schedule, launch, and run Docker containers across a cluster of Amazon EC2 instances using a simple set of APIs. You can build and package applications into containers with Docker, and then seamlessly deploy the applications into production with EC2 Container Service. EC2 Container Service manages a cluster of Amazon EC2 instances for you and takes care of the state of your cluster, as well as scheduling, running, and monitoring containers across your cluster. EC2 Container Service schedules containers to help find the optimal placement based on your CPU and memory needs.
Okay, so ECS is basically our container service that we shipped. We also have a couple others. We have EKS for Elastic Kubernetes Container Service. We also have Fargate, which is ECS, where you don't host your own virtual machines and manage those beneath it. They run on our VMs, and so you only have to pay for the container.
Less ops work, my fave.
Less ops work and less cost, which is closer to the serverless type model for cost, which is really nice. So there's multiple offerings here, and Other customers are actually using a full-blown Kubernetes install on their EC2 instances. So there's lots of options. Some people use Docker Swarm. These are all tools that are going to manage our containers for us. We're going to focus in just on ECS for the rest of this. For one, it's the only service that fully supports Windows containers for now. It's in beta in Kubernetes, and so when Kubernetes fully supports that, that will then move into EKS as well as the Kubernetes that you run yourself. And so anyway, when we look at ECS on Server 20 or for Server 2016, the first thing we do is we build a cluster of virtual machines. Once it builds out that cluster, then we can start to build tasks that run on that cluster. And so it basically builds up the instances and has them all configured to work together. And then you create a task definition. And that's the definition of what you want to run there. You know, pull from the container registries to run these containers. I want to run 3 copies at all times and multi-AZ or, you know, that kind of stuff. If one fails, start another one.
Yeah, if you're not familiar with this terminology, the easiest way to think about a task definition is like one application. So in our case, we have 2 images to run one application, so our task definition would refer to 2 images.
Once you have that task definition, you create the service. And when you create the service, it basically says, all right, this app, which has these features of this much RAM and all these different constraints, I'm going to run. And in this service, I want to run 3 copies at all times and do all that other stuff. So you define the app, basically what it needs to run, and you define what you want to run as far as in the service, and then it launches and manages that and keeps it up and running. And you can specify how it stops them and starts them, how it load balances across them if there's multiple copies, that kind of stuff. So let's take a look.
If you notice in that diagram, also he had a highly available environment because he had multiple services running in each cluster, and he had a cluster in 2 different subnets, so in 2 different regions. So it was a highly available environment. I don't know if you paid attention to the picture, but just wanted to call that out.
So here I'm in the AWS console environment, and I've gone to ECS. And the first thing you would do is create a cluster. And so when I create a cluster, I get to choose, am I doing Linux or Windows?
I don't know. Which one ever could we be doing?
I think we're going to choose Windows.
You think?
And then we give it a name. We basically select our instance sizes that we're going to run. We select how many we're going to run, the number of instances, and then the EBS storage, key pairs if we want to remote into these instances. You can also use your own images. You don't have to use the pre-built image that we have. And then you create a cluster. Now, I've already baked one because it does take a little bit to build. So if we look at my cluster, it's this Windows container cluster. I know, a unique name that I gave it, but it's up and it's active, and I've got 3 servers running it. So basically 3 instances. If we look at the tab here, there's services, tasks, ECS instances, metrics, scheduled tasks, and tags. If I go into the ECS instances, that's going to show my EC2 instances here. These servers, if I go into the EC2 section, are going to be listed there as well. They're the servers that I'm running on. And I've got 3 of them active. If we look, 2 of them are in AZA, and 1 of them is in AZB. So I do have it set up in a multi-AZ environment, and it's ready to host the services. So the next thing I would do after I create the cluster is I would go create a task definition. And this task definition, I've already created one called nerddinner-prod, because this is my production environment.
I just want to say, like, if you're creating a task definition and you already wrote a Docker Compose file, it's pretty easy to just fill in the pieces from your Docker Compose file. It's asking a lot of the same questions.
So as I build this, excuse me, what it basically wants me to do is select name and services it runs under, but the important part is this part right here, the container definitions. So I have 2 container definitions. I have the Nerd Dinner DB production and the Nerd Dinner web production. And in these, when I define them, what I basically am doing is...
You map the ports.
Mapping the ports and giving the ECR, the registry of where those images are that I'm going to pull it from. And so you configure it with that and how much RAM it's going to use. So I've given these both 500 mega RAM. So they're looking for a gig of RAM to run the both of them. And they're going to run them both on the same server the way I have them configured. So basically, that's all I need to do is create that task. Once I have that task, I can go back to my cluster. And in my cluster, I go and I create a service. When you create a service, it basically takes your definition of a task, and then it says what cluster you want to run on, because you might have more than one cluster. And then you say how many of those tasks you want to run, and you go into some health checks, because it can restart stuff. You can go in what kind of deployment do I do? Do I do rolling updates, or do I do other types of things, blue-green deployment? And let's go back here. So what we have is we have our service up and running. We see that we desire 2 tasks to be running, and we have 2 tasks up and running currently. So with that, I know, very cool stuff.
So this is just a diagram that's really nice. It shows kind of how things are working. So you see Amazon ECR on one side, because that's where our images are. And then Elastic Container Service is actually wrapping everything. So you're going to define your application. That's the task definition. And then you can choose to launch it on EC2 or Fargate. So Fargate is actually commonly it's confused as its own service. It's just a launch type inside ECS. So if I choose Fargate, I'm saying I would like to manage a lot less, which is my favorite thing in the whole world. And then from there, you can manage containers.
And Fargate does only support Linux today. Soon to support Windows.
Today. Okay, so we touched on this in the beginning, but again, this is the easiest way to start modernizing your application and not have to do it in one fell swoop. So if you lift and shift into Windows containers, you can then break apart pieces of your .NET Framework application. So you can say like, oh, this is a reference API. All this does is load up the dropdowns, and then you can start rewriting that in .NET Core, and then your .NET Core container can speak to your Windows container, and so you can start breaking out pieces of it into .NET Core until you have the whole thing broken out. So you can basically turn your application into microservices at that point, and also rewrite it in .NET Core at a slower pace than just, I'm going to rewrite the whole thing before I move to the cloud.
This is a very interesting way that some consultants and things, it's on the internet, that they're rewriting these .NET apps without changing. You don't even need the source code to the host app, to the traditional .NET app, right? It runs through a proxy, and that proxy then puts a new front end on the old set. And so you start doing the new code, and you can do that in .NET Core and modernize the app. No touching is required to the legacy app. Very cool to be able to build that. And then the other side of it was you don't even have to test, like, the aspect of, did it change things, because you're not changing
Regression testing?
Thank you, regression testing. Yeah, one of those words that you devs use.
One of the
That's what
words.
I was looking for.
One of our vocabulary words.
All right.
So yeah, this is the GitHub. You can replicate everything we did here in the directions file. It's a markdown file. Should be right in the GitHub. And then this is our information. If you have questions, that's my Twitter. I'm on Twitter all the time, so feel free to reach out.
And if there's any questions, we do have microphones here. We do have just
we have a minute
34
left,
seconds.
so we might have to walk out and take questions outside.
But yeah, we can certainly answer questions if you want to talk to us at the end too.
When you start to break out microservices from your monolith, and you do that with .NET Core and Linux, can you mix and match in your Docker Compose file, and does that actually work?
Yeah, well, you can have another container running Nginx as a proxy, and then they can communicate.
Yeah, and as far as your Compose file, you're starting up containers. You could have containers start up.
Oh, right, yes.
That are Linux containers that start up Linux
Yes.
stuff. You can have Windows containers start. Yeah, so yes, you can combine that.
All right, we got to get out of here.
All right. Yeah,
We're getting
thank you.
kicked out. Thanks, guys. Oh, please fill out the survey. Hopefully you liked
Top
it.
scores. And I'll buy beers. So there's a lot of you here, but I'll buy beers if you see me tonight.
Yeah,
As long
the
as I
pub
get a
crawl.
top score. Thank you.